To today's webinar on monitoring change with ERDAS IMAGINE. I'm Gareth Cronin. I'm the local government account manager here at IMGS, and with me I have Lauren Lucas, who is a engineer. Lauren's going to bring you through today's webinar on monitoring change with ERDAS. So just for 2 minutes, guys, I'm going to start.
Okay guys, so thanks for joining us this afternoon. So as Gareth said, my name is Lauren Lucas, and for any of you out there that attended our IMGS 2016 day in Dunleary just a few weeks ago, this presentation is similar to the one that I gave on the day, except this is going to take a more technical view for monitoring change for ERDAS IMAGINE. So the agenda I'm going to cover today is why should we monitor change, solving problems. So I'll demonstrate some technical ways that you can monitor change using ERDAS IMAGINE, and then we'll do a quick wrap up. So why monitor change? Well, monitoring change can help you make informed decisions, and this is the best way for if you need to make an argument as to why you would need to monitor change. It really is a decision-making process, and the great thing about monitoring change is that you can build it into the processes that you already have running. So you don't need to. This doesn't need to be a separate entity. You can have it as part of your business workflows. So it's also very good for the effective distribution of resources, and we'll be looking at that in relation to utility companies later on. And the main thing to take from this slide is that the best indicator of future behaviour is past behaviour. So by monitoring change, we can begin to establish some normal behavior over time. Images, for example, over a period of time, we can begin to identify what is normal. An example of this would be vegetation. So we might analyze vegetation throughout the year and start to identify what it should look like in summer versus spring, etc. Now what we can do is we can start to analyze those features and see where there are divergence from the norm. So who does monitoring change apply to? So we have different industries like local government, exploration, natural resources, defence, and utilities. And some of those are going to be covered in the following examples. So solving problems with the power mechanism. So in relation to monitoring change, today I'd like to take this approach so that we'll look at what is the problem that you have, what analysis can be applied, what are the results, and what is the action that can be taken from this. Might just maybe get a check if everyone can hear us okay.
Just literally send the message in the comment section. So can everybody hear us okay?
I'll continue anyway, but just pop anything into the comment section if you've got any concerns. Okay, so solving problems, environment or agriculture. So the problem could be the analysis that you might want to undertake is a vegetation health index, and we'll take a look at an example of one of these in a few moments. The results, you might find that there's actually an infestation of the crop, and the action would be that you would apply appropriate treatment before further spread of that infestation. So I'll just switch over now and do a quick demonstration of an NDVI. First thing that I want to do is show you the imagery. So I first want to introduce you to the concept of an NDVI, and then we'll look at the change detection. So for the concept, I'm going to show you some blue sky imagery kindly provided to us by Blue Sky. So for anybody that's not familiar with ERDAS IMAGINE, this is the user interface. So you can see that it's a fairly intuitive interface that you have here. If you want any more information on some basics of using ERDAS IMAGINE, please do get in contact with us. We'd be happy to help. So I'll just change the spectral band. Okay, this is some nice high-resolution imagery. It's a nice vegetated area, so this will be really good for doing an NDVI. So again, an NDVI, so it's normalized difference vegetation index. So this is the analysis that we spoke of in the last slide for checking the health of, or greenness, if you want to say, of vegetation. So how it works is you use near infrared bands and visible red bands to determine the greenness of the vegetation. So I'll show you how that model will work. We'll just have a quick look around the imagery so you can see that there are some bare lands, there are some roads, and there's some quite dense vegetation. So what we'll do is we can do a change detection, or sorry, we can do an NDVI and then compare to this original image and see how it looks. So I'll just open up Spatial Modelers. This is a great tool. I'm going to open up my NDVI model. Okay. So here we can see, I actually haven't written this out anywhere because the Spatial Modeler has a fantastic little tool called Preview, and it's brilliant for if you are quite complex model. You don't want to have to write out your data every time. You can use this preview, and it'll let you see what you're doing as you go along. It'll also let you change things in the model as you go along, and it will therefore change in the preview window. So we can have a look at an example of that in a moment. Okay, so I'm going to just run this model now. Run the preview. Okay, and I'm going to close out the original imagery just for a moment so that you can see it better. Okay, so here we have, now in NDVI, the output is from -1 to +1, depending on the health of the vegetation. So any of these darker colors here, that's indicative of either non-vegetated areas or poor health vegetation. Like for example, this area here, we might compare that to the original image in a moment just to see what that is. And any of the really dry colors is quite dense, very healthy vegetation. So if I just scroll in here, you can see because it's such high resolution imagery, you can actually begin to pick out where the rows of trees are, which is quite cool. And definitely one of the benefits of using high resolution imagery. So what we'll do now is I'm actually going to open up a new data window. And show the original image. And I'm going to link these views. Okay, so here in this area, let's see if I can change these specs. Might help you see it a little better. Okay, great. So you can see in these areas that there are some trees with some shadows, and they're actually picked up. Those individual trees are being picked up, as you can see the bright signatures there. If we scroll maybe to another area, like the big black area that we saw earlier on, again, you can see these pathways, as they have no vegetation, they are a negative value, a black value. Oh, here we are. Okay. So as you can see in the original image, there is some dense vegetation surrounding the area. So as you scroll in, it appears to be maybe bare soil, or could be even a harvested crop. So it's good to know that it will show up those differences in the image as well. Okay, so that's the idea of an NDVI. So now we're going to have a look at using change detection with an NDVI. So vegetation is a really good proxy for a lot of different types of change in an environment. So vegetation can be a proxy for obviously the health of a crop. It can be a proxy for urban growth. So you can start to analyze where there is either more or less vegetation due to the change in land use. So for example, I'll show you an example now in a few moments where that's the case in Dublin City Centre. So yeah, it's quite good, and there's also another index that we'll take a look at in a few moments called the water index, and that will help you to analyze flood risk areas. Again, that's using the moisture content of vegetation and soil. Vegetation is quite a good proxy for a lot of different aspects that you might be monitoring. So we can just close this out now, and I'll move on to the second part of this demo. Okay, the first thing I'm going to do is I'm going to show you the imagery. Format. Okay, so we have some Landsat imagery for the Dublin City Council area. It is being clipped down just for convenience. The top image that you're seeing there is from 2015, and the below image is from 2013. So straight away you can see areas like the Phoenix Park are different already. That's because these photographs are taken in different seasons. So it is important when you're doing change detection, especially with imagery if it's in relation to vegetation, that you take into consideration the time of year and the health of the vegetation. You know, if it is of a normal status, then you can compare like for like. But if you have vegetation in winter versus in summer, you're obviously going to get a lot of different spectral reflectances for each pixel. So it's important to note that. Okay, so this is what the data looks like. I will show you the model. So again, what you can see here is an NDVI model up here and the exact same down below. Now I've added in some bits and pieces and we'll talk about those in a moment, but it's good to note that with change detection, in Spatial Modeler, it's as simple as using a subtract tool to subtract one pixel of an image to the corresponding pixel of another image. That'll give you the differences, and we can have a look at how that works in a few moments. So up here we have, you can see we have the 2015 image. For the NDVI, we have used a near infrared band, which is band 4 in this Landsat image, and visible red band, which is band, or sorry, and the near infrared, which is band 5, and the visible infrared, which is band 4. Again, as an NDVI, the actual algorithm is near infrared minus red over near infrared plus red. So that's what that crazy looking thing there. And then what we've done is we've actually gone and categorized it. So the reason I've categorized it is because for this model, I'm actually interested in only vegetation. I'm not really interested in any urban settings. So I know just from context that anything that is less than a value of 0.1, anything less than that tends to be non-biological matter. So it tends to be concrete or non-vegetation in this case. So that's why I've categorized them out, so it'll make it a little easier for me to identify where these vegetated areas within the city are. So what we can do is, as I said earlier, this little preview tool is great. We can just run this up here. And what I'll do is I'm actually going to run this preview straight off just so we can have a quick look at what a categorized NDVI looks like. So remember, this model is the same as what we used for the previous blue sky image. It's using Landsat imagery, which is a little lower resolution. So here we can see, if I actually close this out now. Okay, so you can see that's what it looks like. So where the last image was varying scales of grey, I've gone in using this little sub-model here to apply some colour. So I've been able to apply some colour and also actually some attributes. So I can say, you know, vegetated area, non-vegetated area, and here you can say I can apply a colour to each of my different categories that I've specified. So if I go across here, so again, if I zoom out, you can see that this is a repetition for the 2013 image of what was done above. Again, there is some categorization. There is a submodel to color to add some color, and what I can also do is I can attach the previews here. I can actually just remove those. Don't want to spoil the end result. I can move that there as well. Okay. Now, what we have here is we have a subtract tool. So again, this is literally just taking both images. It's as if it's sitting them on top of each other, the younger image on top of the older image, and asking for every single pixel in the image, is it different? So it's subtracting the value of one pixel for the corresponding pixel in the other image. So I know that can be quite confusing if you can't see it for yourself. So if you do have any questions, please do not be afraid to ask. And then I'm going to categorize, I can see in a Boolean language. So again, I can run a quick preview out. Okay, so what we can see here is, Okay, so what you can see here is that you have areas of change within Dublin City Centre. Now, it's really important to remember, as we said, that there are different seasons that the image is taken in. So some of this change might just be that the tree canopies have fallen. So it's really important, context is really important. It's the same with the sea level. Is the sea level higher or lower at certain times of year? This could be to do with this little line of strand along Bull Island. So what we would like to do is, I'm going to actually close the model, and I'm going to open the original data. We can open 2015, and then I'm going to open the output of that model on top of it. So if I move the categorized NDVI to the top, you can see it's still in black and white. So while it's quite useful to us that we can use still and swipe back and forward with the data, it would be better if we could use some translucency. So I'm going to close that transition. I'm going to right click and display the attribute table. I can come down here, I can change that this uses opacity. So I'll put that right up at the top. Great, so that's taken out the black, but what I'd also like to do is just make that a little bit more obvious. If I can put in some orange maybe. Okay, so I can see here there's a key area. I've actually done this demonstration before if anyone attended our user group. So from that demonstration you would know that this is actually from the Dean's Grange area where the new DIT campus is built. So if we have a quick look at, maybe if we just open up 2013 again. And use a swipe. Okay, so that slight change there would actually be quite difficult to see if you were trying to do it with the naked eye, and that's why we use these kind of tools like ERDAS IMAGINE to identify these changes for us. So that's just one example there. Clear these out.
Very useful.
Yeah, it's pretty good, and I have to say, again, you can, I think in the last demonstration we did that, you can export that out to KML and you can put it on Google Earth, which is quite nice as well. Okay, so the next section is using NDVI for parcel analysis. So again, this is something that might be of interest to local councils. I spoke about this at IMGS 2016, and it was to do with, better full screen. Okay, so this image here is a blue sky image again, and it's of Wexford. So I used an NDVI to pick out the buildings. I wanted to pick out building areas and then identify where there was change between one year to another. So as you can imagine, if you were using, especially if you're using nice high resolution imagery, this kind of analysis is really, really useful for the likes of a legal build. So taking on the para mechanism again, we can look at so that there's a possible illegal build. You've done your NDVI, you've done your change detection. So like the model I just showed, and the analysis you've searched for urban change using an NDVI, and the results that you've identified a couple of possible sites where there could be an illegal build. And what you want to do as the action is then you can go and inspect that site, but at least it's a targeted site. So it's all about, this is what we were talking about earlier on, about the distribution of resources. So you can go to a targeted site as opposed to sending a worker out to check an entire neighbourhood. So that's quite a useful application. So here's just an example of that. Because it's high resolution imagery, I just have some images of the actual model that was performed to save some time. So this is the NDVI. Again, you have the darker areas are non-biological matter, so buildings, roads, any concrete surfaces, and the really high signatures, such as the likes of here, are all those kind of field and dense vegetated areas. So let's say I've done my change detection and I've identified these two areas, and I think that there could be a possible illegal build. So what I might do is I might add a third-party data set on top of that. So change detection is not, as I said, it's not just a separate entity. It's about building it into your process. So you can start to build it into other data sets that you might have. So I have some planning data for the area. This is kind of provided to us by Wexford. So I can go in and I can see, you know, okay, this area here has a planning application, it doesn't, and you know, you would obviously, if you were working in the council, you would have better knowledge of whether that was new for this year or depending on the change detection that you've done. So you'd be able to go and say, you know, that's a possible illegal build. Let's go and have a look at this site. Okay, so solving problems for emergency planning. Okay, so again, using the PAR mechanism, the problem is that you resource action during flooding. So this is quite important, especially when you consider the likes of 1 in 5-year floods, 1 in 10-year floods, or 1 in 100-year floods. So areas that might not normally flood, but given a forecast, it'll allow you to prepare for such an event. So we can do some flood risk change monitoring and some flood modelling. So the results from that would be that you would identify areas that are of high risk, and you can map out alternative routes to your resources, or you can map out where protection would need to be placed for assets. So again, this would be perhaps you know that south of a river X floods every year, but given a 101-year event, north of that river may be more adversely affected depending on the properties of the area. So I'll just do a quick demonstration, but just here's some context for that demonstration. So I've taken some land of the Midlands, the nearest rainfall station of which is in Gertine. So some context here is that in December of 2014, 98.2 millimetres, which is roughly 10% of the rain for that year, fell in December. In November of 2015, it was 16% of the rain fell for that year. And in December of 2015, it was almost 20% of the rain fell for that year. So again, this is just, I thought about if I was doing flood risk modelling, what would interest me, and I thought about how last Christmas there was some very bad flooding, so that's why I chose these months. And I wanted 2014, December of 2014 to December of 2015, just for a good comparison. And you can see there are stark differences there. So I will move on to the demonstration first. Okay, so firstly I'm going to show you one of the images, the 2015 image. Okay, input. Okay, so this image might be a little bit dark. I hope you can see it. So basically, I want to focus around this area. Now, this is for 2015, so remember this would be one of the more flooded images. So it's not the norm. See that, and sorry, there might be just a little bit of background noise. I'll try and raise my voice. Yeah, so you can see that there's quite a lot of overflow from the river. So if I was to do an analysis on the water content of vegetation in this area, similar to what I mentioned earlier, this is the normalized difference water index. So I'd be able to do this kind of analysis between 2014, December of 2015, and see what areas have changed, and also use November of 2015 as a bit of context for that as well, just to to show that it was quite an abrupt rainfall event. It was the gradual build-up. So what I can do now is I can go ahead and show you the model that was used. So again, this is the NDVI. So what we have here is, again, I'm just using the preview because although the model writes out fine to an output, it is quick and easy for me to use a preview, and that's what I tend to use. It's really great. I actually might even just show you an example of how it works in a moment. So I have my input image here. So this one is, let's say, we take the December 2015 image. Click OK. Again, what I have is, so whereas an NDVI is near infrared minus visible red over near infrared plus visible red, an NDWI is shortwave infrared, which is band 7 in Landsat 8, minus near infrared, which is band 5 in Landsat 8, over shortwave infrared minus near, plus shortwave infrared plus near infrared So that's quite a mouthful, but I think you get the point. And again, what I've done is I've categorized it. So I've taken out some values which will show greater areas of flooding. Again, if you're going to do these kind of models, it's just good to get a bit of context on, for example, like earlier I was able to tell you that any values less than 0.1 for vegetation are not really relevant. So you kind of would need to get just a few bits of that information to run the model. But the great thing is that once you have the model built, that's it, you can just run it. And I'll speak about how you can automate these kinds of models using smart maps towards the end of the presentation. So I have a sub-model built in, again, to apply some color. And I'm actually going to show you an example of how you can use how the white preview is so great using that in a moment. So I'll run this preview. Great. Okay. Now you can ignore this section here, this blue section, because it's a little bit changed by some cloud that was in the image. But it's okay, it's another area of focus anyway. So hopefully this is clear enough that you can see. But you can see that these blue areas, now down here we have a lake. So it has defined water bodies, but what you could do is you could add in some vector data and subtract those areas out so that you're only looking at areas that are not water bodies. But just for the purpose of this model, I didn't do that. So, but that's definitely something that you could do. So you can see, you can follow near the line of the river, but you can also see where there is clear overflow of moisture. So basically, again, just a little bit more context. So what you're looking at here is the drier areas are these lighter browns, and the more moisture that's in the soil is the darker brown, and then the really wet areas are in blue. So if I go and I'll just show you how the preview is probably one of my favorite things. Go over here, and I can say, change that blue to yellow. We'll run that through, and that changes. I didn't have to run that model out again to see how it looked, but it's not just from a vanity perspective, it's also very functional. So again, if I wanted to, I could go in and I could change the track to take out this category, click OK, see what happens. So again, these kind of changes would take a little bit longer because you're actually affecting the values, but you get the idea that you can go in, you can manipulate the data without ever having to write it out. And there you go. So I've actually subtracted the highest value there, and it's showing that there's no data in that area because I have told it not to categorize it if there is. So what I can do now is I can clear these two out. What I can do is I can show you the output of the 3 NDVIs that I performed for those data sets. December 2014, December 2015, and November 2015, just to give you a quick look. So again, as you can see, I mean, this whole presentation is about change detection, but really that change detection is just the final step. It's all about processing your data, what you're looking for. It's all about the context, and that's why I think that change detection is such an important process, because it's actually so simple. Just to add in that final step. I mean, I guess the main thing that you could do if you wanted to try and implement these kind of processes would be every day and ask, is there a simple step that I could be taking to monitor change in this variable? Okay, so I think this is a really good indicator. This is fairly clearly the line of the river as it flows in this area. I think the rainfall station that we're using is down in this area, somewhere around here. So you can see the line of the river fairly clearly. And if I turn that off, you can see November of 2015, and straight away it's very clear that there is not as much rainfall in November of 2015 as there was in December of 2014. So, and I'm pretty sure if we actually check that on the stats that's accurate. Yes, no, actually it's not. Okay, so maybe there are some other factors in that. It could have been the months leading up to this area here. The months leading up to this could have been drier, and maybe that's perhaps why the soil is showing up that it's actually drier in these areas. This area here is actually bogland. So it's always going to have a high moisture content, but again, that doesn't mean that you wouldn't need to know if it's going to flood pretty badly. So if we compare November 2015 to December, you can see there's a huge difference. So again, this is the change that we want to identify. Again, there would be absolutely no harm in going in and using vector data to extract out your lakes and your rivers so that you would purely get the change in areas for land. But as you'll see now, I will show you our change detection. So we've got a change detection. Again, this follows the exact same model as I showed you a few moments ago. It literally subtracts one image from the other. So it's subtracting December of 2014 from December of 2015. I'll go in here and we'll have a look at it. Again, so as I was saying, it actually, because there is no change in the river itself, it will not pick it out. So you don't even for the purpose of change detection, you wouldn't even need to extract those water bodies. It would be purely for visual purposes, because if the change detection is clearly identifying means the lake nor the river has changed, therefore it is not highlighted. However, the banks around, you can see there's a stark change. So if we take that as context, if we take the context that we had in the earlier slide, so where there's almost a 50% increase in rain in that 1 year, so you can imagine if your average is, say, that 98.2 millimeters per year as it is in 2014, if that's your average, you can say, okay, if there's a 50% increase in rainfall, what areas are at risk? And that could be your one that enables you to start forecasting and start planning for those kind of events. But another great thing is that you're not limited to vectorize this, and you can send it out to KML, and that's what I'm going to do at the moment. So I'm actually just going to start up Google Earth so it can be warming up. Okay, so as that's warming up, I'm just going to show you the vector version of this. Again, I did this really quickly within ERDAS IMAGINE, but I want to just move it on a little bit because I'm wary of the time. That's loading in nicely for me there. I'm going to do that. I'm just going to move these. Okay. So here you can see is a vectorized version of the data. So this is, again, quite useful. So you can go in ERDAS IMAGINE and you can do all your analysis, and with the click of a button, literally the click of a button, you can go and you can change, raster shape file, there you go. With the click of a button, you can go and you can vectorize that data and add it in with your other data sources. So it's all about making it another resource. So if I go to the help, this little actually help search is great for if you want to find something really quick. So I can connect to Google Earth because it's already open. That's why I had to open it first. Get out of there, and then I will export the overlay. So if I do that, switch to Google Earth. Give it a moment. Okay, so Google Earth is not responding. Okay, but the idea is that you will actually see that vector data set then in Google Earth in the correct location, which is great. It's very useful, especially if you need to disseminate this information really quickly. So if you get told that next week there's going to be an inordinate amount of rain, you need to get the information to, it could be your staff. You could say, look, listen, I need you to go and make sure this asset is protected. It could be your local area that you need to tell them, okay, look, these addresses are at risk. So it's a really good way to disseminate the information as well. Okay, so we will move on swiftly.
Enjoy the live demo.
Oh yeah, absolutely, absolutely. Oh, there you go. Okay, so it's worked. I've been told before not to work with children, animals, or live demos, and I'm starting to believe it. Yeah. So okay, there we go. So as you can see, yeah. So that's you can see again. As I was saying, there's the line of the river going through, and it's also good for a bit of context as well. If you want to see why why a particular area might be showing up, you can have a look at it there. Okay. So we will go back to the presentation. Next, so solving problems for utilities. Okay, so this is another little demo that I did last time. In relation to change detection for point cloud, so I wanted to take utilities because I know that there would be, for example, power corridors would often be surveyed on a regular basis in relation to the proximity of a tree to power lines. So if the problem was that you had safety concerns for your staff and the public in general, and maybe you could be concerned if it's during high winds, the trees could be too close, or in general the safety concerns that you would have around staff going out for tree cutting, etc. So the analysis is that you could do a 3D power corridor analysis. So this would be taking point cloud data collected. It could be from helicopters, it could be from UAVs, whatever your source is. But you can analyze these power corridors. You can detect if the vegetation is too close, and you can dispatch your tree cutters to the correct location. Again, this is what we're saying, the importance of distribution of your resources to the right location. So it's saving you time and money and effort. So I'll do a little quick demonstration to show you that. So we can clear this out. I mean, as you can see, like I've been kind of floating around ERDAS Imagine for the last little while. It's very easy to use. Again, if you'd like any further information or demonstrations on ERDAS Imagine, please don't hesitate to contact us. So what I'll do now is I will open a point cloud. So here is a power corridor, an example of a power corridor. And what we can see is, now in 2D, point cloud doesn't really look that impressive. But the magic of ERDAS Imagine is that it has this point cloud tab which allows you to do all manner of cool stuff. So straight off the bat, you can go in, you can have a look at it in 3D, which is the point of having point cloud data. So you can go and pan around it. So I will zoom in now. Again, this might be a little difficult to see, but if you have a look carefully, you can see that you can actually see the power lines and the pylons as you go along. That would be a power station there. So we can zoom in. I might even actually color that differently. That might help. Okay, so that might help us pick out some stuff a little better. Let it load up. Okay, there we go. Okay, so you can see the power lines are changing with height. So the tips of those power lines are red. And you can see the trees. And so yeah, it's quite cool to go in and have a look around. But what can we use this for? So what I can do is there are some nice tools that you can, nice point cloud tools. So I can go in and I can have a look at the rectangle profile. So I can just draw a box here. There we go. Okay. So it's notoriously difficult to work with point cloud data in general just because of the size of it. So I'd always recommend trimming down your data set to an area that you're looking at. So what we can do is I'll let that, there we go. There we go. Let's try that again. Much better. Okay, great. So now I can go in and I can have a look at these different areas and have a look at the profile views. So while that's loading up, you can see that it's taking this area and it has created this big white area to show you exactly what you're looking at. So, yeah, absolutely, yeah, it's great. And you can even, what I really like is that you can rotate this block and it'll show you a different view of the profile, which is really handy, and you'll see why now in a moment. If I make this area just a little smaller, perfect, and then I can move it over here. Because I want to have a look at the power lines and what we're saying about measuring the distance between trees and power lines. So if I rotate this slightly, not a little bit too far. Okay, so yeah, you can get the idea. You would rotate it so that you can get the best view of where you want to take your measurement from, because that's what I want to do. I want to measure the actual distance between the power lines and the trees. So if I click on the profile that I want to measure, I can go up here. There's a little measure tool, which is very useful. And I can say, okay, what is the distance between here and here? And it'll start giving me some nice, just click, and you've saved however many man-hours of sending somebody down a corridor, analysing all the different areas. So you can do multiple measurements and it'll start recording them for you. So it's really, really useful. So again, the reason that I'm showing you this is because you can start automating this process for change detection. So using smart maps, you can automate this kind of workflow, and it can send you a report. It can just spit out a report to you at the end. And you don't even have to have an expert. You don't have to have desktop software, and that's really, really the magic of it. So that's completely free of using this ERDAS IMAGINE software. It would just be that you'd have the workflow scheduled and automated. So now if we just hop back to demonstration. Okay. Great. So in a nutshell, so change monitoring assists your decision making. It has multiple use across a plethora of industries, as you've seen. I've been able to talk about a load of different kind of industries there, and the models can be automated using smart maps. Again, it's really important to emphasize that it's just a further step in your analysis, and it can be built into your processes. It doesn't have to be a separate entity. So I just want to thank you for your time and let you know that our next webinar is on the 26th of July, and it will be given by Kira Belly, our FME professional and FME trainer, and it's going to be on FME server and FME cloud. And if there are any questions, if you want to just pop them into the comments box now at the moment, we can answer them for you. Or if you don't want to ask us right away, you can definitely send us an email. That is no problem at all.
That's brilliant. Thanks for that, Lauren. So if anybody has any questions, feel free to just add them into the comment section there.
Okay, so there's one in there just asking me to go over the difference between an NDVI and NDVI. Okay, so the main difference is that an NDVI, so vegetation index, it uses near infrared and visible red, and it analyzes the greenness of the vegetation, and that's based on the properties contained within the chlorophyll of the vegetation. An NDWI analyzes the moisture content of soil and vegetation. So that's the main difference. And an NDWI, the water index, uses the shortwave infrared and near infrared bands. Thank you for the question.
Anybody have a question?
Oh, there's one in there about the Landsat imagery that I used for the Dublin NDVI analysis. The question is what resolution is that imagery? So that's Landsat 8 imagery, which is typically 28-meter resolution. So as you can see, compared to some of the other demonstrations that I did, if you can get your hands on some high-resolution imagery, definitely do, because it will make your analysis an awful lot more accurate. However, it is perfect for that kind of analysis if you're just doing you know, larger scale analysis. And again, yeah. So I mean, Landsat 8 imagery is also free, which is a nice perk too. Good question, thank you.
Anybody else with a question? No, that seems to be it. I just want to thank everybody for attending today's webinar, and thanks to Lauren. She's done a great job. I will email out everybody a link to the webinar so you can view it again if you want to go through any of it, or if you want to show any of your colleagues. Plus, if you have any questions, don't be afraid to hesitate, or don't hesitate to contact me on my email, gcronin@imgs.ie. But you can just reply to my email that I send out to everybody tomorrow. Thank you again for attending. See you all hopefully very soon at the next webinar.
See you at the next webinar. Thanks very much.